All right, let's dive into this paper on Alibaba's new large reasoning model, Marco-o1. We're going deep on this one, folks.
Yeah,
You sent over the figures, tables, the whole shebang ready to break it down.
absolutely.
So this model, it's designed to tackle more than just your standard question-answer stuff, right? It's about these more open-ended problems.
That's right. Marco-o1 is really pushing the boundaries of what we think of as AI reasoning. It's inspired by OpenAI's o1, sure, but it's aiming for something broader. Like, the paper even says it's designed to solve more open-ended problems where a single right answer might not exist.
I like that. Might not exist.
Okay.
Okay, so they get right to it with a great example in Figure 1, the strawberry problem.
Classic.
Right, counting the R's in strawberry shows you how this model reasons, not just spits back information.
And that's a key point. As the authors highlight, the key innovation of these models is their ability to generate intermediate reasoning steps before providing an answer.
They're showing their work, which is totally different.
Exactly. And they do this by using a combination of 4 key techniques.
Let's hear them. Technique number 1.
Chain of thought fine-tuning. They're training the model on data sets that include not just the answers, but also the reasoning steps to get there.
So it's learning to think like we do, breaking things down step by step.
Precisely.
Okay, what's next?
Technique number 2 is Monte Carlo Tree Search, or MCTS. It's like how a chess AI might work, exploring all the possible moves, potential outcomes before making a choice.
So instead of jumping to the most obvious answer, it explores different reasoning paths.
Exactly. And evaluates them, chooses the most likely path to a solution. All explained in section 3, by the way.
Got it. So it's thinking strategically, not just linearly.
Right. And then it gets even more meta, reasoning action strategies. The model experiments with different levels of detail in its reasoning.
Hold on. It's deciding how to think about the problem, not just what to think about.
You got it. Sometimes big leaps, sometimes tiny steps. The paper calls these step as action and mini step as action strategies. That's in section 4.1.
Okay, I'm following. That's 3 techniques. What's the 4th?
The reflection mechanism. After it goes through a reasoning process, it's like the model asks itself, wait, did I mess up?
It's double-checking its work. I need that feature in my life.
Right. And it can go back and rethink steps, correct errors, especially helpful for those tough problems. Section 4.2, they actually give an example of how it fixed an initial error.
That's wild. Okay, so we've got these 4 techniques working together. But the model's performance also depends on the data, right?
Of course. Table 1 outlines the data sets they use.
They've got the filtered OpenAI CoT dataset, their own Marco-o1 CoT dataset, and a Marco instruction dataset.
A good mix to make sure the model is well-rounded. Speaking of which, Section 3 gets into the details of how Monte Carlo Tree Search works.
Yeah, this MCTS sounds complex. Break it down for me.
Imagine you're solving a problem, right? You could pick the first solution that comes to mind, but maybe there's a better one. So you explore a bunch of options, think through what might happen with each one.
Weighing your options.
That's MCTS. It checks out different reasoning paths, like simulating possible outcomes, and gives each path a confidence score.
The higher the score, the more likely it'll choose that path.
Exactly. It's finding the best route to the solution.
Makes sense. And then there's that thing about the model adjusting how detailed its reasoning is. Step as action versus mini step as action, you said.
Right. It's like solving a puzzle. You can try to put big chunks together or focus on individual pieces.
Choosing the right level of detail for each problem.
Precisely. And that choice can really impact how well the model does.
So it's not just about being logical, it's about being strategic.
Exactly. Now, about that reflection mechanism, the model double-checking itself. In section 4.2, there's an example where it had to understand a complex set of relationships.
Okay.
So it went through its reasoning, made a tiny error in its logic, got the wrong answer.
Happens to the best of us.
But the reflection mechanism kicked in, prompted it to reevaluate, it found the flaw, corrected itself, and boom, correct solution.
Like an error detection system.
It really is crucial for complex problems with multiple solutions.
So I've got the 4 techniques, the data, the importance of reflection. How do they actually test how well this thing performs?
Good question. They use several data sets, one of the key ones being MGSM. Table 2 has the results.
Right, let's see what we've got.
Well, first off, Marco-o1 consistently beat the base model on both the English and Chinese versions of MGSM.
So those 4 techniques really made a difference, not just theory.
Exactly. And get this, different MCTS strategies worked better for English versus Chinese, flexibility is key. Figures 4, 5, and 6 actually show this visually.
Love a good visualization.
Right. It really highlights how effective the MCTS approach is. But then they took it a step further. They didn't just test Marco-o1 on standard problem-solving tasks. They threw translation into the mix.
Ooh, interesting.
And not just any translation, they focused on slang and colloquial expressions.
Which is super tough for AI to get right.
Yeah.
Slang is so nuanced. It's not just about the words themselves, it's the meaning behind them.
Yes. Precisely. And get this, Marco-o did surprisingly well.
No way.
It understood the slang, translated it accurately, kept the tone and style consistent.
This could change the game for translation tools. Imagine understanding the nuances of slang, the cultural context.
It suggests Marco-o1 is getting closer to grasping the deeper aspects of human language, not just the literal meaning of words.
It's going beyond just being a language processor. It's understanding how language is used to express feelings, humor, all those subtleties. And they actually provide examples in the paper, right? Figures 7, 8, and 9.
Absolutely. And they're fascinating. In Figure 7, for instance, they show how Marco-o1 translated a Chinese phrase that literally means, "This shoe offers a stepping-on poop sensation."
Okay, that's vivid.
Right. But the model got it. It understood this was slang for comfortable soul and translated it accordingly.
So it understood the sentiment, not just the words.
Exactly. And in Figure 8, we see a longer phrase describing a stylish outfit. Both Google Translate and Marco-o1 get the literal meaning right, but Marco-o1 captures the tone and style of the original Chinese.
So it's translating the personality behind the words, too.
Exactly. And finally, Figure 9 shows a casual, enthusiastic phrase. Again, Marco-o1 gets the translation right, but it also keeps that informal tone, that excitement from the original Chinese.
It's mirroring the speaker's style. This is a big step forward. We're not just talking about AI processing information. It's about understanding the essence of human communication.
That's a great way to put it. It makes you wonder what they'll be able to do next with this kind of technology.
I know. It's not even just getting the words right. It's about the feeling behind them, the intention.
Absolutely. Language is so much more than just conveying information. It's how we express ourselves, connect, build understanding.
Right, and that's why these slang examples with Marco-o1 are so important. It shows the model is picking up on those subtle things that make human language so complex.
Exactly. Like in Figure 7, where it translated that Chinese phrase that literally means, "This shoe offers a stepping-on poop sensation."
Which, let's be honest, doesn't sound too appealing.
Not at all. But the model understood. It knew it was slang for comfortable soul and translated it perfectly.
It's like it has a sense of humor almost.
Maybe not humor in the human sense, but it definitely understands how language can be used playfully, figuratively.
And then there's Figure 8 with that longer phrase about a stylish outfit.
Yeah, Google Translate and Marco-o1 both get the literal meaning right, but Marco-o1 goes further. It captures the tone, the style of the original Chinese.
It's translating the personality, too.
Precisely. And then in Figure 9, that casual, enthusiastic kind of phrase you'd see in a review online.
Right, and once again, Marco-o1 nails the translation, but it also keeps that informal, excited tone of the original.
Amazing how it can match the speaker's style so well.
It really is. This feels like a huge leap forward for AI and how it understands and generates language.
So it's not just about processing information anymore. It's about capturing what makes human communication human. That's it, exactly. So big picture, we've seen Marco-o1 tackle reasoning problems, explore different solutions, double-check its work, and now translate slang accurately.
It's a pretty impressive model.
It is, and the researchers did a fantastic job laying out their methods, the results, even giving us those helpful visuals.
Definitely makes it easier to follow along.
But even they admit there's still room for improvement. Their conclusion mentions looking into outcome reward modeling and process reward modeling.
To make the MCTS process even better.
Yep. And they talk about using reinforcement learning, too, to fine-tune the model's performance.
Sounds like they're always striving for better. Makes you excited to see what's next for Marco-o1 and models like it.
It does. This whole field of research is moving so fast, it's like we're watching AI evolve right in front of us.
And it makes you think, what's next? What other breakthroughs are just around the corner?
Exactly. This research shows we're getting closer to AI that can not only solve problems, but understand and talk to us in a way that feels more and more human.
The possibilities are kind of mind-blowing.
Yeah.
From better translation tools to AI that can actually work with us on creative projects.
It's a really exciting time to be following this field.
It is. Well, we've covered a lot of ground today with Marco-o1, and I think we've all learned a lot.
Definitely a fascinating look at the cutting edge of AI. It really does make you appreciate the work these researchers are doing. pushing the boundaries of what's possible.
Yeah, it's not just powerful, it's versatile, too. And like you said, they're not done yet. There's always more to explore, to refine.
That's what's so great about this kind of research. It never really stops, always building, always improving.
And we get to follow along, see these breakthroughs as they happen. It's an exciting time to be interested in AI.
It really is. Makes you wonder, what's the next big leap going to be?
Right. What's just around the corner? Well, I think that's about all we have time for today on this deep dive into Marco-o1.
It's been a fascinating conversation.
It really has. Thanks for taking the time to break this all down with us.
My pleasure. Always happy to talk about this stuff.
And thanks to all of you for listening. We hope you enjoyed this deep dive into the world of large reasoning models. We'll catch you next time.